Hey everyone, welcome back to another Fusion tutorial. Today I'm going to show you how I made this DeWALT battery holder. It fits perfectly onto the battery and has really nice tolerances along this curve. It snaps right in with that little button, and you can use these to store your battery, so you can screw these to the wall and then hang your batteries from it when not in use. Or you can design one just to slip onto the battery when you're not using them, just to protect the battery terminals and just make sure not a bunch of dust and stuff get in there. So I have already done this, and I have a model on MakerWorld that's available to print right now. You can print a single one and a few different designs, and then I also have some designs, some holders that have multiple brackets, or actually I guess can hold multiple batteries, so you could print that as well. But today, hopefully you can learn some new techniques with this video, and I'm going to be showing a few things that I've never shown on this channel before with the Surface tab and stuff like that. So if you're new to my channel, I usually try to do these videos in one take, so sometimes I'm a little long-winded, I make mistakes, and I try to fix them. I basically kind of treat it as a live design session with very minimal cutting and messing with the video. So if you don't like this long format, it might not be for you. Otherwise, let's get going. So the first thing we need to do is insert a photo. Now, to make this battery holder, I basically took one photo and I used some calipers, and I took some measurements, and we're basically going to design the whole. I always want to call it an adapter, because eventually I actually do make an adapter from this, but it's really a whole. This one's really just a holder. But I'm going to design the whole holder out of this one picture and some measurements from my calipers. So the first thing we want to do when we import this photo is calibrate it to the right size. So here's our little canvas folder here. We're going to right click and hit calibrate. And I know that the distance from about here to here is 67. Okay, why? Look at this. I'm already having trouble. Now, why won't the, oh geez, it's way up here in the corner. Couldn't find it. So this is 67 millimeters. So now we have the size right, and you can measure off anything. There was really no great place to measure. You could have measured like something down here, like from here to here. But usually when you're calibrating something in Fusion, like a photo, you want to pick a longer distance. Like you wouldn't want to calibrate from here to here, because the margin of error would be a lot larger. Where if you calibrate from here to here, your error will be much smaller. And you know, this isn't going to be perfect, which is why we would print test pieces to get the fit right. So, okay, we have this calibrated, and the first thing we're going to do is draw a profile of the holder, and we're going to use this straight line and then this curve. So we really want to make sure this photo has this ridge or flat area perfectly level. So we're going to draw a sketch on this front plane, and I'm going to draw a line starting at where I normally would want it. So maybe about right there. Zoom out, and we'll end it about here. And you can see it's much lower. I shouldn't say much lower, but it's lower on this right side. You see we're kind of at the top, and we get lower here. So we're going to rotate this photo just a little bit. So I'm going to right click, edit canvas, and there's a lot of things you can do. You don't want to rescale it. You really don't need to move it left or right. We really just want to rotate it. So I'm just going to click on the rotating handle, and I kind of know from experience I'm at about 0.2 degrees off. So you can see it rotated about 0.2, and now we're pretty straight there, and I'm going to hit OK, at least straight enough for this tutorial. Obviously, the more you work on your photo and getting the measurement right and all that, the more accurate your design will be, and the less test prints you'll have to make. So, okay, so now let's draw this curve, and I like to use the fit point spline. There's also a different spline tool called the control point spline. I like to use that when the curves are a little bit more random and there's more of them, kind of exactly what the photo is showing. If you really only have to do one or two curves and you want those curves to flow really nicely, use this fit point spline. So, and you want to use as few of points as possible to get the smoothest curve. You don't want to click here and then do like 10 points here, because you're going to have to be fiddling with all of them and you're going to end up with some waves in here. So let's see if we can just get this with 2 points. So I'm going to click here and I'm going to click here and we'll call that good. Now I'll hit escape on the keyboard to get out of that tool. And now we can kind of manipulate this curve. And we know we want this straight line to be tangent with this circle, or with the radius of this curve. So there's a nice smooth transition here. So I'm going to grab this barbell, rotate it until it snaps to that horizontal line. And now we've just constrained it in this position. And now the only thing we can do is move it in and out. So basically increase or decrease the radius of that curve. So from here, we're going to have to do everything else. And I'm not going to work on getting this absolutely perfect, just because for this tutorial it doesn't really need to be. But there, we actually got it really, really fast. Looks like we could maybe use a little bit more curve here. So maybe we'll move this over and kind of manipulate it a little bit more. Probably should have left it alone. I had it pretty much spot on. There we go. We'll just keep it at that. So there is our curve for the profile of our adapter or our holder. So let's finish this off so we can create a solid body from it. So I'm going to hit L for line tool. I'm going to come up here and I'm just going to make this 2 millimeters. I'm going to drag this line over and draw a line here and draw a line here. Now it's shaded in so we can extrude this out. Now, because we're not making a super complicated model, I'm going to leave this unconstrained for now. You really should probably get in the habit of constraining your sketches. This is one of those do as I say, not as I do. You could do an automatic constrain here or constrain it yourself. If it's a super complicated design in Fusion, Fusion will run a lot slower if you have a bunch of sketches that are not constrained properly. So just keep that in mind. Okay, so I guess before we finish sketch, let's look at one more thing. So this battery is really flat here. So this surface is flat. And then at this little seam or ridge, there's kind of a round cutaway. And I want to mimic that. So even though this is our adapter, I want this ridge to kind of flow into the adapter to make it look seamless. So we're going to achieve that by drawing a circle, and we're going to change that circle until we get the seam where we want it. And I'm going to kind of show you how we do that. So let's create the circle. Before I do that, I'm going to right click on this whole thing, and I'm going to fix it. And that just basically means I can't move it anymore. And I'm just going to do that temporarily until I get this circle right. So I'm going to hit create. We're going to do a 3-point circle. So I'm going to click here first because I want it to be constrained to this point. So I'm going to click here. I will click somewhere in the middle and then somewhere at the end. And you can see how nicely that follows this curve. And now we're going to end up revolving this circle to make a solid body that we can cut away from this body. So we need a line to revolve around. So I'm going to just hover my mouse over the origin, the center of the circle, move my mouse down. You can see it kind of stays constrained to that midpoint or that center point. And now I'm just going to draw a line all the way up. I'm going to right click on that line and make it a center line. So that makes it act like a normal line, but then also it is basically a center line that Fusion will know to automatically revolve this circle around. So let's start making some solid bodies here. So I'm going to finish sketch. Let's hide our canvas. And we're going to extrude the body of our holder out. So I'm going to hit E for extrude. I know this needs to be 60 millimeters wide, but I want to stay center with the origin. So we're going to do symmetric of two sides. So it's going to extrude in both directions 30 millimeters, which will give us 60 millimeters. And I'm going to hit OK. So there's our basic form. And now what we're going to do is use that circle to create a sphere that can cut away from this body. So let's turn this sketch visible again and go to the front view. And you can see when I click front view, you can still see it's not giving me a 2D image. That's because my camera settings are on perspective. I usually work in orthographic. Fusion runs a lot faster in orthographic camera mode, but when you're zooming in and out, it's a lot quicker with orthographic. If I get designing something and I want to see what it's going to look like in 3D, not in an orthographic view, I'll toggle it on real quick and then I switch back to orthographic. Just keep that in mind. So if you're in a front view and you're seeing the 3D view still, just switch that camera. Okay, so let's go up to bodies and let's just turn that first body off, and then I'm going to select half of this circle. So I'm going to hold shift. We don't need that one right there, but we do need down here. So we have that circle selected, and let's go to create, revolve. And I guess I didn't have to hide that body. I'm going to turn that body back on. And you can see when I turned that first body back on, the sphere now wants to cut away from it. But we want to do the opposite of this. We want to cut away the part that's left and keep the part that's in the sphere. So we have to change this to intersect, meaning whatever these two bodies wherever these two bodies are intersecting each other, we're going to keep. So I'm going to hit OK. So let's hide the sketch, and then let's turn that canvas back on. And oddly enough, we got that almost exactly right, which is pretty shocking. You can see that curve fits. Now let's say we wanted to get this absolutely perfect, and it looks like this could get raised up a little bit. So it's a little far down. So what we can do, I believe we have to make this circle a little bigger. So let's go back into our sketch. We're going to go down to our timeline and double click. And I'm going to dimension this circle. So that's what the dimension is now. I'm going to make this circle just a little bigger. So I'm going to do maybe 180. And then I'm going to come in here and rotate it. Now it's locked at that. It's going to rotate around this point since that is where it is constrained. Just going to make sure it lines up with our body. I'm going to hit finish sketch. And it didn't make much of a change. So let's go back into the sketch and let's do 190 and we'll see if that moves it up a little bit. That still looks pretty good. Finish sketch. And I'm not sure we're making a much difference here or not. Let me get back in the sketch. Let's just do something ridiculous like 250. Now I made it much, much bigger. Let's rotate that. Let's hit finish sketch. And I'm making no difference at all. So why am I not making a difference? Now I know why. So I'm not making a difference because I forgot to keep the revolve tool or the revolve line locked to the center of this circle. So I need to do midpoint, this line to this circle. Now when I finish sketch, look what happens. That line moves way up because now it's actually revolving around this line in the center instead of getting pushed over. So remember that when you do that, when you make this initial line here, make sure you lock it into the center of that circle. So let's go back to like 190. Let's rotate this so it stays on the edge. I'm not sure how important that is, and that's pretty darn close, but not close enough for me. So I'm going to, let's do 185. That stays pretty close there. Finish sketch. Okay, we'll call that good. That's pretty good. So now when we hide this canvas, we have our flat side and our rounded side. So now when we print this out, that's gonna that seam is gonna kind of run into this adapter, and I think that's a pretty cool feature. Okay, so now we can kind of move on from this photo. We won't really need this photo anymore. Not really to design anything, just kind of for some reference. So what we want to do now is shell this out, because this obviously needs to be hollowed out. And I know as soon as I say, hey, we don't need this canvas anymore, here I go, turning it back on. All right, where am I at? Okay. I know that this lip right here, only because I've done this, I've designed this before, and I spent a lot of time getting this right. I know this lip that contacts the battery needs to be about 1.5 to 2 millimeters long from here to here. So we're going to hollow this body out by 1.5 millimeters, or shell it out, you might say, in Fusion. So I'm going to click here with the shift button, and then I'm going to shell this out to 1.5 millimeters and hit OK. I also know, let's go back to our front view. I also know that the distance from this surface here to this surface here is about 5 millimeters, and we're going to want some clearance in there. So I'm going to now make these side walls thicker. So we have 1.5 millimeter, 1.5 millimeter. So we need to increase it by 3.5 to get to that 5 millimeter thickness, but we want to actually do a little less than that for some clearance. So I'm going to do press pull. Actually, I lied to you. I'm going to do offset face, and we're going to come in like 3.3. And you can't just extrude this, by the way, because watch when I extrude this. It doesn't follow that curve. Extrude just goes exactly straight out, where offset and press pull will kind of follow the geometry around it. So I'm going to hit 3.3. So now if we click here, hold shift and click here, the width between here on the battery is 50 millimeters, and we're at 50.4. So we left ourselves about 0.4 millimeters of clearance. And that might seem like a lot of clearance, but remember, this is a tool battery. So there's going to be like dirt and grime that gets in there from being used. So you want a little bit more clearance so this operates smoothly, even if you have like an older, dirtier battery. Now looking at this, we didn't really do much with the back. The back is not very important right now. Obviously, we're not going to keep the back like this. You could extrude this out to make this 5 millimeters as well. So if we go back to that, let's go to that front view. We know we've got a lot of room here that we can create that wall thickness. Where's my, let's see if I can show you that thick. So there's the outline view of my body. So here's our wall thickness. So we have a ton of space we can extrude this out. But what we want to do right now is test the fit of this curve before we go much further. So by the way, if you're hearing me click some keyboard, click the keyboard. If you're on a Windows, if you hold Control, which means it's probably Command on a Mac, this is Control 6, the view, the model view I'm doing now. You can do Control 4, and it'll give you the view with no edges. Control 5 will give you the invisible edges, so the edges you don't see. And you can go all the way up to Control 7 Control 9 for different views. So if you kind of want to quickly toggle between things just to get a better view, you can use those keyboard shortcuts. So as I was saying, at this point, what I would do is start test printing this, because before we move on to the rest of the stuff, the rest of the design, we really want to make sure this has a really nice fit. And if it doesn't, we're not so far along that we can't go back into this sketch. Of course, we locked this, so you'd have to unfix it, but we can go back in and start messing with this curve, right, to get that perfect fit, and then it'll update the rest. We don't want to get too far into this build before we get this perfect. So what I would do here, and this will probably be a good place to end this part of the video. I might make this like a 2 or 3 part video because it gets pretty complicated from here. I would do an offset plane, and I would start here. I would bring it in somewhere where we have some flatness here. Just hit OK. And then I would split this body up. So I would go to Modify, Split Body. We're going to split this body, and we're going to use that offset plane and hit OK. And now you can see we have 2 bodies. So I could turn this one off, and I would send this to my printer right now. I would print it out. I would test the fit on our battery, and I would tweak this until I got it absolutely perfect. Once it's perfect, obviously save it, and when you save it, you can put a little note on there on the iteration that you saved, or that iteration. You can write perfect front end. But what else you can do is then I would join this back up once you have it perfect. Join this back up, and you can make a copy of it. So you can just click on this body, hit move, and create copy. Drag this over and hit OK. And now we have an exact copy, and you can like name this body perfect front end. Get your mind out of the gutters. This just means perfect curves. Again, get your mind out of the gutters. Now we can just hide this body, and we have that perfect shape saved forever. So if we do end up messing things up, we have something we can fall back on. Even better, you could at this point turn these into components. So each then component would have its own timeline. So you could right click this body, create a component, right click this body, create a component. And then as you're working on the original, if you screw up, you can just basically switch over to this one, and you'll have a fresh timeline again. There's probably better ways to do that, but that's kind of my suggestion. If that's wrong, or you have a better workflow, and leave me a message in the comments. But okay, I think we are going to stop here for this video. I'm already at 22 minutes, and the next video will pick up where we left off, putting all of these internals in. And this is where it starts getting interesting. The second video, we'll start working with some surfaces. I'm going to show you guys how to do boundary fill, which is a really, really cool tool. I'm no expert on it. I know just enough about it to be dangerous. And I'll show you some quirks you might run into with making a model like this. And this actually is this will give us perfect examples of what you have to look out for. So, okay, we'll see you in the next video.